Hey guys, new day, new target to look into and hack and see what we can make out of it. This time the so-called OBI Energy Tracker, which is most likely a German only thing or even like different countries around Germany, but it's not an international thing, as it also seems or was claimed that this device is made by OBI or by an external company for OBI, and as it seems by some Chinese company for OBI, but not like Tuya and that's it. But let's see where we go. The interesting part is really that these are now available for like 15 euros in the store and sometimes even for like 10 euros the complete set. And what they are, let's just show it on a real device. You have basically this infrared receiver and transmitter, which you put on top of your electrical meter. So this communicates or mostly reads the data that comes out of your electric meter and is then sent by 868 or 900 megahertz to this other device, which we can maybe get out of here, which is the gateway. And this then communicates via Bluetooth Low Energy to the application to configure it, as well as via 2.4 gigahertz to the Wi-Fi and basically into the cloud from OBI. There are a few videos around it that explain how to set it up, so I will not go around that. And it's also not my interest for this video. And there's also a quite interesting video from OBI and Amazon where they talk about how really the system works in the back end, how the communication works to the gateway and to the app, how the over-the-air updates are triggered and so on. It's of course not protocol-wise described, but the general block diagram out of the cloud. And yeah, you can take a look at it. It's nice to see how open they are about it and the claimed security. Yeah, let's just check where we end up with this. I previously checked out the MAC address from a Wiggle found device, and if you search that MAC address, it shows that it is an ESP32 or an Espressif MAC address, so we already know what's inside of here. And for the reader, there was a blog post which claimed that this is the so-called BAT32G135 SoC inside, which is like an ARM core, very simple SoC, 64 kilobyte of flash and good for low power stuff. And additionally, a LoRa wireless module, basically. And that assumes now that in this gateway is another of these LoRa modules. And what is now interesting is, for once, how do these devices communicate with each other? Is it like encrypted? How is the key exchanged? Because the manufacturer OBI claims that in the future they will offer to have multiple readers for one gateway to be connected and are in beta phases and so on. But really, let's see where we get to this. I did open up one more, and since they are so cheap, it's really not so important if one is broken or not. And this is the reader, basically. You have here an infrared sender and receiver. You do have a USB-C plug, but this one is mostly or intended to be powered by two AA batteries. And other than that, we really have like here this LoRa module, as well as the claimed SoC. And other than that, some other parts for like a voltage drop, so a voltage regulator if you power it by USB. Some transistors, most likely to handle the battery connection. It has an external antenna which is glued in the plastic case. This one is also like screwed, this case, so you can open it up and could reflash it, because they were so nice to leave some test points here if the focus would work, to connect something to it. There might be the readout protection enabled of the chip, but you would most likely, or can most likely, just erase it and rewrite it. So if there ever would be a custom firmware, you could write one or write one into the SoC without problems. On the other hand, the ESP32 side, so the gateway side, we do have here behind this sticker an ESP32 C3. It's also now the first time I'm seeing it, with 4 MB of flash, and it seems like 4 MB of PS RAM, so quite nice. And under this stacked setup of the PCB, you have also the same like LoRa module as on the other side, and of course a power supply. So it's really just like that, and what else should it be? Other than that, we also have like the antenna for the LoRa part. The ESP32 uses the internal antenna. It's their decision, of course, especially if you have like the other metal part under it, but they will know what they are doing. The naming on some parts are Chinese, especially on the reader. You have a few namings here in Chinese, so it really seems to be a ready-made solution where OBI just offers the firmware, or even the firmware is somewhere at that part and OBI only does the cloud part. It's nothing we can know right now. Maybe if we are able to dump out the memory of each, we can find some strings and maybe see some text if it is made by OBI or someone else. From the forum posts where one OBI employer is talking as well and writing some interesting infos and claims what features next come. Yeah, let's see how it goes. Here we also have these test points, and these are fitting to the ESP32 pin out. So we have UART, the enable pin, and the bootloader pin. So we can just connect a UART converter and try to dump it. If this flash is encrypted, let's see if we can somehow decrypt it and maybe glitch the ESP32. I don't know if there are any exploit already for the C3 variant. Let's just see. Other than that, I did take a look at the OBI application beforehand, and the way it works there is you have the My OBI app, which is really like the big OBI app where you can also order your products from OBI to be delivered or picked up in the store. Not so important, but they implemented it right into this app, and it is most likely or a mix of getting users into the app by this device and or just like getting more advertising out of it. I really don't know, because the 10 euro price point they sometimes offer is just impossible to get this hardware for. I mean, you can get it, of course, the PCB parts alone, but not the complete set of parts. It needs to be a mixed investment to some extent. Not so important. But I did look into the app, and there seems to be quite a lot of encryption happening. The basic way it works is on boot or in connection mode, the gateway sends out BLE beacons or BLE server stuff, which has the OBI / and then 6 characters as a naming. And this naming is sent to the cloud, and from the cloud there comes back a 16-byte key, which is used to encrypt the connection from the OBI app to the BLE device. So without this 16-byte key, you will never be able to communicate with the device itself. And furthermore, after that, they exchange a key, or more likely a certificate. And as it seemed, they also exchange a private key to the gateway. And it seems this is then the private key for this device. And if it's all true, we might be able to just replicate the Bluetooth connection, get the key for the Bluetooth connection out of the cloud, and then do our own certificate and send this own certificate to the device in the hope that the URL can be set somehow, or what else we can do with it then. This is all just rambling and without showing actual stuff, but I just got them and I will now take a deeper look, try to dump the memory out of both, will update you on it, and then try to reverse engineer it a little bit. And yeah. Quick update already. On the transmitter SoC, it seems there is some kind of debug lock enabled, because every time you try to connect it, it directly resets the SoC, and it seems to be some kind of watchdog timer that is enabled directly at boot. And if we hold the SoC in the reset state, it is possible to connect it, but then no further action can be done, because in reset state no flash is available and no real registers are working. And the moment we release reset again, the SWD interface faults again. Next part, the gateway, also a step closer. I tried to connect via the UART connection to the bootloader, and this is permanently disabled in the eFuse, unfortunately, on the ESP32. So most likely also the encryption is enabled. So that way, even by desoldering some flash, which is, I don't think, available on the C3 version, that did not go further. What I next did was try to sniff the BLE connection of a real installation via the OBI app, and I was able to get the correct key out of the cloud. That way I was able to decrypt the BLE connection and use this to rebuild a tool which allows to fully control the BLE connection, or basically doing an own BLE connection by reverse engineering the steps. And so far it is really looking like you can even set an own URL to the cloud, so it's possible to send your own certificates after connecting, and the device will most likely connect to your own user-controlled cloud, and that way you could get a full declouded solution. And it's also true, as they said in the video, that this certificate you get for the installation is most likely only valid for around 5 minutes. And only after having a full connection, the cloud will directly send to the device, to the gateway, this persistent certificate. And then this will be true, and the device is basically fully locked to this state. But what else I can show is I tried a few rounds already, as you can see, to send a bit more data. And if I now connect to the device, and we are happily connected to it, and just to give more infos to it, this is the BLE name, and you can find it by just sniffing or looking at BLE devices. And if you use this string with the cloud, you get back this key, and this key is of course universal or different for each device, but you can get it. And after being now connected, you can do some basic settings, like setting the Wi-Fi and the certificate. But you can also send, as before, a very big text, and if you do so, you not get an answer back, but you get a very nice buffer overflow of the device and a reboot. So since we have a UART connection, we can see what is happening. And if that is not the perfect way to dump out the full memory in some way, what else is? So that will be the next step, to dump the ESP32 with this buffer overflow. And directly some good news as an update. So the reader firmware is still not dumped, but good news on the ESP32 side. While this is now quite a hassle to explain this, the previously mentioned possibility to set a certificate while being connected via BLE is correct, and you can even set your own URL. And I'm using this now to make an MQTTS server, send out the certificates via BLE to the device, which it happily accepts. It will then request a new set of certificates as this persistent certificate, which will be saved and then be used to connect to the cloud again, and it will be happily connected already. So this does work. And after now figuring this out, I did on the other hand also connected the device to the real application, to the real app and cloud, and triggered a firmware update that way, and disconnected everything again, made some kind of a man-in-the-middle server. So we provisioning the gateway with the BLE tool to our own cloud, to our own server, and our own server again connects to the real cloud, like in the man-in-the-middle way, and then intercepts what it is talked. And one thing that it is now talking is the ESP32 firmware. And not only is it in clear text, but we also have like the complete firmware. And currently it even does not look like it is signed, which would be, the next nice part, because that means you can just simply flash your own custom firmware, and you really only need this T key, this TEA key once from the cloud. And since this is a hard-coded key, you just need it once. And also there always needs to be a possibility to get it out of the cloud, at least in the current way the system works, because the real OBI app also needs it to connect to your gateway. So that's right now quite nice to see. And yeah, let's continue on this. We can now take a look inside of the firmware. We can further check if we also get in the same way a new update for the reader part. And again, after a bit of tinkering, some nice results. While the reader firmware was still not be possible to read out via the SWD interface, I have some good news on the PC in a moment. I did continue on the firmware downloading and extraction from the cloud, and it turns out by just searching for further firmware versions, you can also get like older and even newer versions. And then further down, looking inside of these firmware files, the ESP32, and reverse engineering those, which is very nice and works perfectly, we can see that inside of them is also again some smaller firmware versions, and in some are existing more and in some just one. Turns out, if we take a look inside, this is then the firmware for the ARM SoC that is on the reader, and this will basically just be uploaded to the reader automatically when the gateway is connecting to it again, and so on. And that's quite the nice news. What else did we have? So it turns out that while the bootloader from the ESP32 is locked, we do still can connect to it while the firmware is running. And we do get back now some of the loggings, but there is a hidden XORed command handler basically, and you can do a bit of, I would say, end-of-line testing. You can read and set the T key, the BLE ID, and the UUID, which is basically the unknown value you need to know to do a very first BLE connection. So if you do not can get it via the cloud anymore, there might be this solution, or there is this solution, to drill some holes in the plastic case and access the XORed interface that way, and just read out the unknown values, the hidden values, or even like write new ones. And what you can also do is like read the Wi-Fi credentials from the factory, which are just simple, the BLE name. I think they do also test the Wi-Fi and also like this LoRa test transmit. They do at factory to test if the LoRa module works fine and have somewhere else a receiver for it. So that's quite nice. So we now have two ways of getting the T key that is really like needed. And so you can read it out via UART, or you can get it from the cloud if it is not closed anytime. Other than that, I did now install a sensor at my meter and was able to make the MQTT server locally running and bind the reader completely. And you can see now every 15 seconds a new reading is transmitted from the reader to the gateway. And you have here the actual values. So for once, the energy values and the negative ones will not increase because it's dark outside, but this would increase if the solar power is increasing and so on. The next step I did was also to implement the firmware update function in the local server. So it's now possible to upload a new firmware to the ESP32, which then again could also upload a new firmware to the ARM SoC. But since it is actually proven that the firmware is not signed, you can definitely update a custom firmware to the device without the cloud and just by knowing this T key, of course. But yeah, still unknown how to get it without drilling a hole or the cloud. Other than that, while now connecting the sensor, the reader, it turns out that the old firmware this was shipped with, the 31 firmware, did still use a very rudimentary XOR or encryption of the packages from the reader to the gateway. And in the latest firmware, the 57, I think, and the 1.2.1 on the gateway, this connection is now a full encrypted one with public key exchange. But funny enough, the gateway can just simply send a new public key or vice versa. So while the reading is secure, you can still just compromise each of the device or play around with each of them wirelessly. Could even upload a new firmware onto the board, onto the reader, without knowing anything and completely wireless, which is not the right thing to have, but maybe they will improve in the next time. And yeah, other than that, this will all get uploaded to GitHub, and this should be basically it. What you could now do out of the values is really make the best Home Assistant plugin, which with now the known values and so on, the known MQTT protocol, you can fairly simple create that. It needs this MQTTS server, so it's not very simple but doable.